Hi students, today we're going to continue learning about congruent triangles. In the last video we talked about transformations and how they relate to congruency. Today we're going to decide if triangles are congruent based on these tests. So these tests are like shortcuts. And so what we did in the previous video was we decided what congruency meant and how it related to transformations. And we measured two triangles, which, by the way, I failed to say in the previous video. How do you think I made these triangles? Well, I just copied and pasted them on a computer, so of course they were congruent. But we measured each piece. This side had an exact match. That was a set of sides. We knew two sides. So did these. We knew two more sides. So did these. We knew two more sides. We knew these angles had an exact match. So we knew two angles that matched. And we knew two more angles. And two more angles. And so we had to know 12 pieces of information to decide that these triangles are congruent, to be exactly the same size and the same shape. 12 pieces of information. That's probably more than we want to have to know all the time. And so that's why we have these shortcuts. And so we have shortcuts with the S's and the A's for the sides and the angles. And so if a set of sides matches, then we're going to use an S for it. We're going to let that be one piece of information we need to know. So we're going to manage by knowing 6 things instead of 12. So 2 things that match, 2 other things that match, 2 other things that match. Okay, so we're going to cut the information that we need to know in half. And so we kind of like that. So I kind of want to show you how and why these work. And so I think you can still see me a little bit. So as far as things we did in class, we talked about angles and their relationship with the side opposite them. Small angle, small side opposite it. Big angle, big side opposite of it. We need a little more information to know for certain that those pieces are the same. But if we have that other information, then if we know this angle, then we can assume something about the side opposite it. Or if we know this side, then we can assume something about the angle opposite it. And that's what all of these congruency tests hinge upon. So we've got 3 segments that are different lengths. So we're going to make some triangles out of. So we're going to take these and try to make triangles. And so what this is just a set of sides that match. See if that one will stay a little purple. All right, a set of sides that match. And another set of sides that match. And then we can tell the long one apart. Okay? And so by doing this, well, we could take it, but we've already decided that these 2 pieces are the same, and these 2 pieces are the same, and these 2 pieces are the same. And as a result, since these 2 pieces match, the angles opposite them also have to match. What we knew was this set of sides. So we know a set of sides. And then what we can assume is that we know this angle opposite as well. We didn't know it. We don't have to know it because we know these sides. We knew that these sides matched. So here's another set of sides that we know something about. Since these sides match, these angles across from them also have to match. We didn't know it. We weren't told it, but we can assume it because of that relationship. Angle, opposite side. One matches, so does the other. These sides match, and so same thing. Since I know something about these sides, I didn't know about these angles, but now I do. So every piece has a congruent match, and that was our definition of congruent triangles. So by knowing these 3 sets of sides, I now know that these triangles are congruent. That is the side, side, side test. And so instead of having to know also that all the angles matched, well, by knowing that just the sides match, I know that these triangles have to be congruent. And so that is the side, side, side test. And so side, side, side just means that there are 3 sets of sides that we know have a match. And that if that is the case, everything else has to have a match also. And so these are congruent by the side, side, side test. A harder example of what that could look like might say something like D is the midpoint of segment AC. Well, we would have to take that information and know that that means those 2 pieces are congruent. Might would have given us this information, and still we're looking at it and we only see 2 sides, but look at BD. It's in this triangle, right? It's in this triangle. It hadn't changed any between them. So always be on the lookout for a shared side. If there's a shared side, it matches. And so these would be congruent by the side, side, side test. We know a set of sides here, we know a set of sides here, and we know a set of sides here. So we get to decide that they're congruent by knowing less information. Okay? All right, next is the side angle side test. And so we know different information to start out with this time. I'm going to try to draw the same triangles each time and just show, hey, we're knowing different stuff. And so if we knew those angles and we knew these sides, then we have a set of sides and another set of sides, and we have an angle that is in between them. Literally, it is the angle that is formed by those 2 sides. And that's why it gets to be called side, angle, side. The placement matters. It's not like we can pick a point and go clockwise or something. We're looking at how the sides and angles relate to each other. Okay? And so we could get the straws and things out again, and we could just see that literally if, we'll do it real quick. Let's see. I'll just move this and have the orange background. So if we had these angles, so I know what you're looking at looks like a triangle, but let's just consider that all we're caring about is that these angles here match. Okay? And we've still got these sides that we knew to have some similarities. And so we want to see if there's any way that we can arrange these where they don't exactly match. So we're just trying to make it match around that angle and know that 2 sides have to be there. Well, matches. Okay, if I'm going to have, oh, you can't see it all. If I'm going to have 2 angles that are the width of that purple mark, and I'm going to have this side and this side, then there's not anything else I can do. This side has to finish it out. It has to. And that's because by knowing these sides, I knew something about the angles opposite them. And by knowing these sides, I knew something about the angles opposite them. And I didn't know this side, but I knew this angle. And so by knowing these angles, I knew something about the sides opposite it. And so side, angle, side is a valid test that works. So a harder example of that could look like that same one we just said. But maybe again, it said that D is the midpoint of AC. We would need to know this. And this time, maybe it said BD is perpendicular to AC. Well, that would tell us that there's a right angle, and so is that. Now, I know I used right angles as examples in these 2, but I didn't with the straws. Doesn't have to be a right angle here, just any angle that matches. But here, these would be clues that would have to help us make some more connections to figure these out being congruent. So midpoint, those pieces are congruent. Perpendicular, those pieces are both 90 degrees, and we see a shared side. And so a side, an angle, and a side. And so these are congruent by the side, angle, side test. All right, angle, side, angle. Again, order matters. And so this time we know two angles and a side in between them. And so it's really important that we know that it's the side that is directly in between them, collinear with them, if we wanted to say. If we trace one angle and then we trace the other angle, we know that this is angle, side, angle because the side that we know, we've traced it twice. It is a part of both of the angles that we found. So angle, side, angle test. One thing to look out for anytime angles are involved is vertical angles. So if we were told that C is the midpoint of AE, so we knew that side. And if they had told us that A and E were congruent, but nothing else was said, well, we should still look here and see vertical angles. And then we should see we have an angle, a side, and an angle. The side that we know is between the angles that we know. And so this is the angle, side, angle test. All right. Oftentimes students get that confused with the angle, angle, side test. And so, like I said, I'm going to draw the same triangle picture and we're just going to know different information. We're going to know the same angles, but this time we're going to know a different side. And so we need to see that since the side isn't in the same place, it's a different test, but still, let's see some things. Here's an angle that I know has a match. Here's an angle that I know has a match. And here's a side that I know has a match. If I did the same thing, if I traced both angles, then I'm only hitting the side that I know one time. The side that I know is not directly between the angles that I know. So this is angle, angle, side, because it is not between. Okay. The other thing about both of these with two angles in them is that you still have all pieces represented. I knew this side, so I could assume something about this angle. I knew this angle, so I could assume something about this side. And I knew this angle, so I could assume something about this side. All the pieces were represented. I knew this angle, so I could assume something about this side. I actually knew both of these opposite pairs, but the interesting thing there, because otherwise it wouldn't work, it shouldn't work. But if I know two angles and these triangles match, then what do I know about these third angles? That's a theorem that we learned about, the third angle theorem. I mean, just like the ones, if this was the picture we were working with on the front, if this was 60 and this was 90, what does this angle have to be? It has to be 30. If this one is 60 and this is 90, then this angle has to be 30. So now we're making another connection. We're knowing something else is true. And if these angles match, then the sides opposite them do as well. Every piece is represented. So it's a shortcut. Instead of having to know all 12 things, instead of having to know 6 pairs, we get away with just knowing, well, there was an angle set, there was an angle set, and there was a side set. Okay? So with these, there's some practice questions we're going to look over in a minute. But there's one more type that we need to see doesn't work, and one more type that we need to see does. So kind of weird to see a not example, but side angle is not a test. We've got that. Why can't we have side angle? Well, for one thing, it just plain doesn't work, and that's what we're about to see. But if you can't remember that, just remember we don't want to write it backwards on a test. So side angle does not work. But I do like for you to see why it doesn't work. So here's a side that matches, remember? And here's an angle that has a match. Remember, we're not looking at the whole white piece that looks like a triangle. We're just using that angle, and that angle has to be kept the same. All right? So we're going to put these here. Now, I could finish this out in this way. I could. And with all of the others, when I could do it, I had to do it. There was literally no other way I could have rearranged them. And if you don't believe me, cut 3 different sizes in 2 sets and try to rearrange things. And if you've got side, 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 there's nothing you can do to have a triangle that isn't congruent. Okay, but with these, here's the, let's see, should do it. So angle, side, side. All we're saying is that we have to let that angle be represented. And we've got these 2 sides. And the angle is not between the sides. Okay? So, let's see. Let's let it be. Just got to find the right 2 to play around with, because the sides have to be what matches and the angle over here has to stay the same. But if I could take this, all right, I just got to get them set straight. Okay. So we're letting it say that here's the angle that matches, here's the sides that match, and here's the sides that match. I could make a congruent triangle with that happening, but I could also take this side and I could swing it in and I could make another triangle. I could fit this right here. And I haven't changed this angle. And I haven't changed this side. And I haven't changed this side. But I have changed this other one. I was able to create a triangle that works with an angle that stayed set and 2 sides that stayed set. But I changed the other side and I was still able to connect it in 3. So see, it could work here, but it could also work here. And that's because since I only knew 1 angle, I couldn't assume a 3rd one. I couldn't use the 3rd angle theorem, and I just didn't have all opposite pairs represented. So all I knew was these 2 sides, so I could know something about an angle opposite them. But there's this whole angle and side set here that nothing was known about. And so it just doesn't work. So side-side angle just plain doesn't work. But we can have a special version of that. And so this isn't on your note sheet, but it's something that we should add in. And so, like we said, side-side angle doesn't work. But there's a test called HL, which stands for hypotenuse leg. And so if we have a right triangle, and all these that I've been drawing on your note sheet were right triangles. If I start out with a right triangle, and if I know that the hypotenuses match, and that a leg matches, well, technically this looks like a side, and an angle, but it's just a special version since it's a right triangle. So side, side, angle, hypotenuse, leg, that's the version of it that works. And it's because you already know the Pythagorean theorem. If this was 3 and this was 5 and those are congruent and they match, well, I don't know that side, but I could say 3 squared plus x squared equals 5 squared, and I would solve it to get x equals 4. And I would do the same exact thing with this one, whatever it is, and I would get it to equal 4. So since it's a right triangle, it has some special things that can happen. So hypotenuse leg is a test that works as well. All right, another one we can't have is angle, angle, angle. And so we looked at in the previous video that if I had an equilateral triangle, it doesn't necessarily mean that all equilateral triangles are congruent. So I could have another equilateral triangle and, well, we know that this angle is 60 and so is this one and so is this one. And so all of the angles have a match because it's what's true in an equilateral triangle, but they're not congruent because they're not the same size. So angle, angle, angle doesn't work for congruency, but it'll come back to us sometime later. All right. And so some examples of those, you will have And so just real quick, all right, that's enough information for you to decide the congruency test for these. So try that while I'm drawing out the other one. All right, if D is the midpoint of AC, and we did one like this, then those pieces are congruent. If BD is perpendicular to AC, then those are both 90-degree angles. And we also see the shared side. So this would be, I have a set of sides, I have a set of angles, and I have another set of sides. So these are congruent by side, angle, side. It's always good just to mark the information we know. So if that is true because they told us so, and if they told us this midpoint thing, well, if we didn't know anything else, then that wouldn't be enough. But we see vertical angles, and so we know that they are congruent angles. And so here is an angle. I have another angle, and I have a side that is in between them. And so this is the angle side angle test. All right, so we covered the second part of this, decide if triangles are congruent based on these tests. So we know what the tests are, and we know how and why they work. And so we should be able to identify some congruent triangles based off of that. Thanks for watching. See you later.